We shall start now. Okay, come back to Matlab. Okay, I will create workspace first. Okay, and closing closing all function that we already developed. Okay, we will write the new script. Okay, we write the new script. Okay, we starting with, we would like to solve the catenary cable, right? At this moment, I will create the subprogram instead of the function. So I will not define the function. This is a subprogram. This is a subprogram. It is not the function. Okay, it is not a function. Because the function you already know. Okay, so now I will move on the M file instead. M file that is something like the subprogram. When we write the program, normally we may starting with some comment that we write in the program for what. Okay, for this case, we write the program for catenary cable. Okay, we will write the program of catenary cable. Okay, and we will save it in what? I will save it in this. Okay, we may use the name is maybe cable or something. Okay, okay, cable. So right now we save it in directly Matlab already. This is in cable. Okay, and then what next? Okay, we may starting with the basic one. The basic one that is, it should be when we would like to solve the configuration of the cable, we have to know the horizontal tension first. So the horizontal tension should be input from the user. So I define T0 as the horizontal tension. And how to input? We use the command input like this. And this is just the information. Okay, in Newton, it is just like this. Okay, this is the semicolon. Okay, and after that, we have to know the weight per unit length. Okay, the same thing. Input. Okay. And after that, okay, for the cable, in this case, I think it's maybe not we use the equation. We use the equation that we have to set the coordinate at the bottom of the sack. Okay, we have to set the 0 over here. Okay, so it means that the coordinate, the origin of the coordinate system, it should be at the stack, at the smaller stack one. Okay, so it should be set over here. So xa is mean that xa, for this case, xa I define that it should be on the left hand side. XA XA is just from this side, just the dimension from this side. Okay, line like this. And for XB is on the right hand side. It's on the right hand side, XB. Okay, XB. What does it mean? It means that the cable is maybe not the same. How can I draw? It's maybe not the same. Maybe not the same position. It's maybe the support A and support B is maybe not on the same level. Okay, it's not maybe not in the same level, but for the original case, it may be starting with the same level first. Okay, so XA is defined to the left and XB is defined to the right. Okay, so don't worry about this too much because we don't focus on the solving of the cable problem. This is just the example for the Matlab. Okay, so for this case, I will input XA. XA. Left coordinate in meter, but we would like to hint the user that the negative value should be input. It should be the negative value, the negative one. And for XB, and it should be on the right. And it should be the positive one because it's on the right. Okay. Okay. And then we may on this actually is ready to solve. It's ready to solve the value. But if we would like to plot the configuration, it means that we have to define how many points to identify to plot. How many points to plot. For example, we have the value of x for the example. The value of x is from minus 25 to positive 25. Okay, for the negative value of 25 and 25, minus 25 and 25. Okay, so how many points that we would like to plot? How many points? Okay, it depends on us. So for example, we may use the command line space. This is a command in order to digitize the point. Or you may define by yourself. For example, if you define by yourself, it may be longhand. For example, it should be minus 25, minus 24 or something and so on until 25. Okay. Okay. This is maybe longhand. So, but if you use the function, it's maybe like this. Okay. XA to XB. And if you finish, what happened? You will get the X value. You will get the X value. Okay. We will stop right now. You will stop here first. And after that, we will test the code. We will test the code. Just only this this step, just only this step. Okay, you test the code to this step first. What happened to line space? Okay, first of all, we have to go to the directory that keep this file. Okay, what happened if we don't go to that and we type the, how can we call the M file? How can we call this subprogram? How can we call this clip? We just type the name of this clip. This clip is named cable. We type cable. Okay, type cable. And right now the workspace is the same folder. Okay, the workspace, the current folder. Okay, we have, it is in the same workspace, so it can use. Sorry. I have to break it first. Okay, because I doing something that's maybe not correct. Okay, actually, when you working with the M file, it should working in the folder that we have the file. Okay, for this case, the file is in the folder of Matlab. Okay, so the workspace should be the same. Okay, so if we may starting with, if we would like to solve it, if we would like to use this function, this clip, type cable. Okay, we may type the value. The value is 8,000, right? And the cable weight is 80. Okay, this is just minus 25, and this is just 25. Okay, it's already done. Okay, so you see that because we close with semicolon, so it's not display the parameter that we already keep it in workspace. Okay, and you will see how what x is when we use line space xa to xp is automatic develop the number of value from minus 25 to 25, and this type is into 100 node. 100 node. It is tied to 100 node, not 100 element. If you have 100 element, it should have 101 node. 101 node. So for this case, it may be too much for us. It's too much. It's 100 node. It's too much. So how can we define the number of the node? Okay, we can define. For example, if we would like to just divide it into just 20 element, just 20 element is maybe just 21, right? You should have 21 node. Okay, for example like this. Okay, we do it again. Type table. Okay, right now x is reduced to just only 21 node that has 21 element and is separate directly with the, for each element has a length of 2.5. Okay, 2.5. Okay, so for this case, in order to give more flexible for user, we should allow the user to input the number n, that is what? That is the number of node. Okay, that is the value of n. And we change this to be n. Okay. Then the user can allow the user to choose the number that would like to separate. Okay, and then right now we have the vector x already to plot, and then we will find the configuration that is based on the formula. Just type like this. It's a very easy one. This hyperbolic cosine. Okay, that's all. Okay, let's finish. Okay, if we would like to, this step is for what? Okay, and then finish. And we would like to plot. Okay, we may use the command like this, plot xy. Okay, that's all. It's finished. Okay, let's start. Let's try to checking out the script that we already created. Cable, right? And then input the and 25, and then this side is to be 21. Okay, we have the configuration already. Okay, now we have the configuration. So then it's maybe hard to read, right? Okay, we may add some information for the plot. It's maybe like the title. Okay, and it's maybe label the x-axis. Okay, and also label the y-axis. Maybe something like this. Okay. So what's happening? Oh. You have the x-axis, y-axis, and also the title of the graph already. Okay. Okay. This is just only the configuration. If we would like to more information, we may something like this. We would like to solve the maximum tension for each type. Maybe we would like to find the top tension. The top tension is maybe the tension at point A is what? Maybe P0. Multiply this. And also, if we would like to find tension on support B, okay, and also for any point, we would like to find for any point. Okay, we have to use the small x. The small x is a vector, so this is the tension is for any point. Okay, it's already done. Okay, do it again. Okay, to this step, do you have any question? No? Okay, so this is for the tension, right? This is for the tension. If we would like to know more, we would like to know more. For example, the number of arc length. Arc length is maybe S. What? It should be the absolute one. So the detail of the formula you may review by engineering mechanics 1 static, okay? So this is just an example for the coding, okay? And then now we have the value already. So then what's happened? If we doing like this, so we will have the solution. For example, read again. Okay, and number of n is maybe 21. Sorry. My typing error. Okay, so sorry about that. It's my fault. Okay, so we have the graph already. So how about the tension? How about the tension? The tension is stored in the workspace. If we would like to know the tension, just type the tension along the table, something like this. This is the solution. It has 20 points. Okay, and the configuration Y also the same. Okay. Okay, it's hard to read, right? It's hard to read. It's hard to use the value. If you want to plot something, if you want to use this value or something, you have to copy it from the workspace and place it into the Excel sheet or something. It's not convenient, right? And also for the tension on the left hand side and on the right hand side. Okay, this is stored in the parameter. So it's maybe more convenient if we write the output into the file, okay? So right now we will create the file. In order to create the file, we're starting with at the top of the M file. Okay, we have to create a file first. Okay, in order to create a file, you may follow this step. Okay, you assign f name as the name as a variable to store the name of the file that we would like to keep it. You may show the user that it should be the maximum character or something. Actually, it has no, maybe not the limit. It maybe depend on the format of the Matlab also. I don't know the limitation of that. Okay, I maybe forgot. Okay, so this is just the for the detail of the command you may study by yourself. Okay, for the detail. As I told you, the writing programming is just a copy the command that we normally use and to apply it ourselves to be our for apply to our problem. In order to working with the file, we have to identify the file number. FID is the file number, file ID. Okay, for the detail of the command, study by yourself. But if you don't want to know too much, just copy me. Okay. WT is mean writing file. Okay, that is finished. We already developed the file already. And after that, we already have file. That is the ID is FID. The number of file is FID. And then, so now we may write the output file. Write the output file. We will use the command. Maybe like this. Actually, it depend on you. You may adjust the format of the file by yourself. And then this for the title of the file. Right now we will set up the title. Okay, just select T. Okay. Okay. Now we have the title. And then we would like to plot the configuration. We would like to display the configuration. We use the for function I equal to 1 to n. Okay. And after that, we assign the format of floating number. Then it should be 11 digit with 4 decimal point. We have 3 parameter. Okay. And then we would like to write what? The value of x, I, y, I, and also ti. So, and then n. And for the each value of the n should be just what? For the tension, maximum tension, that is TA, and also TB, and also for S. Okay, and then do the same thing, but it's just only one value, is not a vector anymore. Okay, so we use the same thing, it just should be for TA, it's for TB, it's maybe for S. Okay, that's all. You already finished. So what happened? Okay, it's the same. Okay, you storing in the name what? It's maybe example of cable. Okay, I already have this file, but it's okay, that is okay. I may use the same file, ex cable. Okay, 8,000. Just the input rate. 80 plus 25, 5, and then number just 21. Okay, you will see that why n is open, because we forgot to what? Where is it? We may forgot n in some step. I don't know, so forget it. Don't worry about that too much. Okay, I don't know which step, I forgot. The semicolon, I don't know. Okay, right now, so you will see we have the plot already. Okay, and then how about the file? You can open the file. This is the file that we already create, right? What happened? Oh, whoops, sorry. It's maybe something not correct. Maybe something did not correct. Okay, this, sorry, this should not semicolon, it should be colon. Okay, this is the real mistake, it's not set up. Okay. When we develop the code, it's normally we will have a mistake at the first time of the coding. Okay, this is the normal. Okay, do it again. Okay, so yeah, okay, you see this is the output that's already shown in the file. Okay, and at the bottom we have the smaller one. This is smaller tension, the minimum tension that is equal to 8,000, that is equal to horizontal tension, and the maximum tension is at the both end. At the both end, because it is the same level. It is the same level. What happens if it is not the same level? We can do it. For example, it's maybe minus 50 and 25. Okay, and we made this type to be maybe same. Okay, so what happened? You will see the configuration is maybe something like this. Okay, because the x coordinate xa is 50, so this should be the point. It should be more than this. Okay, it's not the shape of the cable with not the same level. Okay, and what happened to the output? Okay, you will see that at point A, the tension it should be greater than the tension at point B. Okay, so this is just only for one configuration. Okay, for one configuration. But if we would like to reproduce again and again, so for example, if I assign you to finding the configuration with the different tension, what happened? For with different tension, for example, the tensions of 8,000, 7,000, 6,000 or something, you have to do it again and again and again. Okay, so it's maybe better if we coding something. Okay, if we coding something, for example, if I set up the step, for example, you can apply it for the senior project or something. If I to develop the computer software. Okay, so if I develop the step, for example, like this, if I decide the step of the tension to be 10 step, for example, like this, actually it depends on you. And then I input the loop to be here. The loop, it should be 10 step. Actually, it depends. You may adjust it by yourself. Okay, it's for the step. And then we set up the step already, and then we would like to plot. Okay, we have to plot, and we would like to plot it in the same figure. We would like to plot it in the same figure, so we should use this command. Hold on this figure, hold on the figure. So it means that we use hold on figure to plot any configuration in the same graph. Okay, and this is 4, and then you do it again and again and again for each value of tension. And then after we finish, we may have to adjust the tension to next step. Okay, and then okay, so we do it again. If we consider the cable number 1, our cable, you will see that it has only one configuration, right? It has only one data. Okay, right now we should have 10 data. Okay, you see, we have 10 configuration like this. Actually, you may adjust the graph, the coordinate or something that is maybe more easier like this, more easier than this. Okay, so if you don't set up the coordinate, origin of the coordinate over here, you may set up the origin of the coordinate over here instead. So you will see the shape is maybe more better than this. Okay, and if we going to see the file, what's happened for the file, we also have the data, a lot of data. It's maybe 10 data, right? Okay, that's all. This is complete of this workshop.